Rather than introduce these fine gentlemen, I'm going to have them introduce themselves and tell us a little bit about what they're doing in the Smack Stack area. And if you guys can just explain what role your product plays in the Smack Stack, tell us a little bit about that. That'd be great.
Yeah. Hello. So I'm Chris Fregley. When the Smack Stack was created, I think I was the Spark. I was working for Databricks, the creators of Spark. And since then, I actually created something called the Pancake Stack. That was a mockery of the Smack Stack. And I was just I think I was in London a couple weeks ago, and someone recognized me as, the pancake guy. So I wasn't sure how to take that. He invited me back to Amsterdam for a smoke and a pancake, which I guess is a common phrase that I didn't realize, which was kind of creepy, but it sounded fun. So Pancake Stack is essentially, the P is Presto, which is something you guys should be looking at. What else? A is Airflow. I have like 3 A's and like Pancake Stack. What's the other ones? Of course, Cassandra. T is TensorFlow, right, which we're doing quite a bit of. And I have to say I've been using Kubernetes quite a bit. So with that, I'm going to hand it over to Ewan. I haven't really done much with Mesos recently.
Hi, everyone. My name is Ewan Cheslak-Pastava. I work at Confluent. We're a company backing Apache Kafka. And Kafka is designed to handle, it's a streaming platform designed to handle very, very large scale streaming data. So it's able to handle actually a couple companies well over 1 trillion messages per day, I think even nearing possibly 2 trillion per day at a couple. And so it handles sort of accepting all that data. We handle integrating with other systems. So for instance, with other systems in the stack, and then also doing some transformation on that.
I'm Scott Livingston. I work at Credit Karma. I don't actually represent any of these pieces, but I'm here on behalf of AKKA. I work on the recommender system at Credit Karma, and we use AKKA in production and have been for somewhere around 2 years now, where we run a cluster that is responsible for actually evaluating all of the data science models that we run when we're trying to give predictions about things for our users. And hopefully this is pretty fun.
Hi, I'm Russell Spitzer. I'm an engineer at DataStax, and we're one of those Cassandra companies. And I spend most of my time working on the integration between Cassandra and Spark. So if you're using Cassandra and you're using Spark, you've probably used my code at some point. As the Cassandra representative, I guess I should tell you Cassandra is a distributed database that does extremely large clusters for extremely large customers and is in use by pretty much all of the big computer companies that are out there that don't have their own proprietary special magic database that they're using.
Hi, I'm Neil Conway. I'm an engineer at Mesosphere. So I work mostly on Mesos. So in that kind of platform diagram, Mesos is the lowest level. So it's basically pulling together all your cluster resources and making it easy for application schedulers, like the higher level parts of the stack, to launch workloads. And something else we do is we work with partners and community people to take the software that is can run on Mesos and package it up into a repository that makes it very easy to install and very easy to run those services. And I think that's kind of an interesting aspect of the way these services get run in practice in modern data centers is that there's kind of a mismatch between the way the software is shipped and the way that you need to run it at scale. Like running Cassandra on 10,000 nodes is kind of a fundamentally different undertaking than running Cassandra on a 5 or 7 node cluster. And so that's one of the things we're looking at is trying to say, okay, what are the missing abstractions that you need to add at the system level, at the infrastructure level, to make it easier to, let's say, upgrade a 10,000 node Cassandra cluster or upgrade a 25 node Cassandra cluster in a way that, it's very hard to solve if you're just the person writing Cassandra or just the person writing Confluent. So as part of that, we're building a new SDK for building distributed services on top of Dcos, on top of Mesos, which I think a lot of this stuff is actually built. When you're running on top of Dcos, you're running it through an SDK we've been working on. Anyway.
What do I do with this? Hello. Oh, this works. This is so strange. Okay, so I've had some people ask me questions I don't know the answers to, and it would be interesting to compare the Mesos and Kubernetes answers to this. The docs I've seen tell me that if I have racks of physical servers, that I could install Kubernetes or Mesos and apportion and schedule the rest of the SMAC stack or whatever you have to run different loads and different machines, and there's lots of strategies for deciding how that's done efficiently and what failover looks like. But if you don't want to run your own hardware and you're, say, on some giant site like AWS or whatever you have, it would be nice if you could just get spot instances when you know you're going to get a heavy load. Let's say at the end of the month, you've got 10x the load you have in the middle of the month. And this happens every month. It's predictable. So what's involved? Is it simple? Is it easy? Or do you need some integration between, say, Mesos or Kubernetes and this vendor such that you can get some short-term, pre-allocate some short-term resources for the impending crush, and once that's over, let it go because you don't want to pay for it? Is that already baked in? Is that hard to do? Where are we at with that?
Great. So I guess I can start answering that question because I guess it's mostly Mesos specific. So I think, so it's a good question, and I think the aspects of that are built in, and aspects of that you're going to have to configure to your particular workload, your particular environment. So the basic notion of looking at your workload and looking at your compute resources and deciding which parts of your workload should run on which parts of your resources, that's kind of core to Mesos and to Kubernetes, right? Then if your set of compute resources is going to be dynamic, so you're going to bring new spot instances online, then it doesn't fundamentally change that problem. Like from Kubernetes perspective, Mesos perspective, you have more resources, your workload is either the same or it's changed, or you're still mapping that workload to the current set of resources. I think part of where something like Dcos comes in, or some of the kind of more integrated stacks around Kubernetes, let's say, is making that more plug and play. So out of the box with Mesos, it would kind of be up to you to, do the tooling to, hook into the cloud API to spin up more resources, or to decide which parts of your workload should run on which cloud resources. Part of what we're trying to do with Dcos is try to give you a more end-to-end experience where it's going to be very easy to point and click and say, okay, I have an on-premise data center, or I have a cloud, collection of cloud resources in one data center, and I want to add some more resources here in a transient way, and to make that kind of a more integrated end-to-end experience. That's not like fundamentally changing Mesos. That's still something Mesos can do out of the box, but to do it right now, there's kind of some degree of scripting involved, partly because Mesos tries to be very flexible, right? So like you don't want to, or the philosophy behind Mesos hasn't been to build into Mesos, like when the system looks like it's busy, spin up extra resources. Mesos is just a very kind of low-level generic scheduler, and then you'd want to build the scripting on top of that to respond to changes in your workload, changes in your set of compute resources. But yeah, like I said, with Dcos, we're looking to make that more plug and play, more seamless for kind of common use cases like spot instances, like transient workload spikes, and so forth. Yeah, I mean,
magically, I got the thing again. Moving your workloads around automagically such that you have locality of data. If you need 5 times, I don't know, let's say the compute resource for 24 hours, I mean, these loads, in this particular case, use case I'm thinking of, it's predictable. You know exactly how much you're going to need and when you're going to need it. So it's much simpler than, say, unknown spiky stuff when some great orange buffoon tweets something and you have things going off, right? In this case, you should be able to plan for that. But I'm concerned about locality of data. I want to be able to push processes aside such that the ones that need locality of data are co-located in the same rack. There should be some awareness of rack. And I guess part of my question is, what's your API look like, and how is it integrated? Let's take AWS, for example, or talk about any other vendor. I'm happy to hear about other vendors in terms of integration, because you need awareness of what rack am I running on, not give me a resource, but where is the resource? What kind of resource is it really? Is there anything in the API for that supports that?
So just to kind of go back to the first part of the question, I mean, I think maybe I made it sound a little too difficult. Like, it's not rocket science. So if you're running your workloads, say on Marathon, you want to scale it dynamically. First you hit some kind of provisioning API on AWS to spin up more resources. Then you increase the number of Marathon instances that you want of your app. Those, so that's kind of like going to be 2 API calls. Exactly when you trigger those API calls, what metrics do you look at, which instances of which apps you increase, and so on, like that's going to be application specific. But it isn't rocket science. In terms of data locality, so most of the components in the stack have some notion of data locality, some degree of rack awareness, data center awareness. Something we're actually looking at doing right now is plumbing that into Mesos itself. So there's kind of a common vocabulary throughout the stack of talking about where resources are located, the zone and the region they're located in. But yeah, certainly each of those pieces of the stack would have some notion of data locality. But you again have to do a bit of work to kind of get all the pieces on the same page in terms of getting everything running local.
So talk about some of the like Kubernetes stuff. So the 2 questions I heard, and I think they're separate questions, are spot instance support and then auto scaling, right? And like scaling up, scaling down. Is that fair? Okay. So and then thirdly, federated clusters as well too. So across on-premise, across like all the different cloud providers, the ability to target specific like clouds during specific times of the day, things like that. So like Kubernetes, and like fundamentally, this is a Docker container orchestrator, right? That's like the most fundamental thing you can think of. There's this tool called KOPS, right? Like KOPS, that has pretty much become the main way to spin up like Kubernetes clusters. It I think now supports not just Amazon, but also like Google, supports Azure, things like that. So. And then as of Kubernetes 1.7, there's now full federation support. There's still one single master control plane, so there's still single point of failure if that master control plane goes down. But at least now you can schedule across all the different like cloud providers. But with KOPS, there's the notion, so this is a separate community tool that works with Kubernetes API that can not only auto-scale the Docker containers themselves across all the different federated clusters, but can also do auto-scaling at the actual node level. So the EC2 instance, the GCE instance, the GKE node pools, I think they're called. And that's also, so spot instances, right? Like that's an Amazon-specific concept anyway, right? It's a generic concept, but that's what you call them within Amazon.
Basically, give me some more compute tomorrow at 3 o'clock.
Yeah. Oh, okay. So like down to that level even. Yeah. So for the spot instances, similar to like Databricks, I'll give a plug for my old company there. You specify the spot price that you're interested in, and if you get them, you get them. If you don't, that's fine. You could have partial spot instances, partial on demand. Specific, like, so actually scheduling more at a certain time. I've never had a use case, or I've never implemented that use case for some reason. Typically it's...
Any business that has end of month stuff has this problem. It's a common problem, I assure you.
Although, I mean, I guess I haven't done it. I mean, I guess with like Databricks, for example, you have these Databricks jobs. I mean, you would just cron, right, like it's basically just a cron job within a notebook, kind of thing. But not only are you specifying the job to run, but you're specifying the size of the cluster, right? So, and which clusters to go to. So I guess, right, like the short answer is all this stuff is either built. Kubernetes 1.7 is which is not out yet. It's beta. I think it's beta 1, beta 2, but supports the federation, and that's the big one. But yeah, the other stuff is all.
But the locality down to the rack level?
And so for the locality, yes, all of Kubernetes is very label-friendly, tag-friendly. So you can label a node GPU, you can label a node. So you can also figure out which regions they're in, which data centers they're in. The rack level stuff, yes, obviously data center, you can label something to like figure out which rack it is. I think the best you can do in cloud would just be the same AZ. Or
Imagine that, say, 25 days out of the month, you can get by with, just some small instances. But 5 days of the month, you need 3 racks. And so what you do is you say, when the day comes up, I want 3 racks. I'm going to shut down. I'm going to move over those other little piddly instances into the racks until I'm done. And then when I'm finished, I'll release the racks and just go back to the lesser. But you need some integration between Mesos and Kubernetes with the service provider in order for that to happen, because the 2 APIs need to have that level of granularity. And I just maybe I haven't spent enough time digging in the APIs, but I sure hope that exists.
Okay, so I think I can get us to a conclusion pretty quickly here. So what you're talking about, you absolutely can do, and you're right that there is a little bit of integration work to be done, but as was being pointed out, it's basically a couple API calls. So what you're talking about, basically in AWS, what you would do is you tag the instances with, at a bare minimum, the AZ, unless you're using one of the weird cluster types that you can figure out whether they're actually on the same rack or not. You actually absolutely have to do this, and the reason I know about this is because when you integrate Mesos and Kafka, so Kafka, you're never going to do this. You don't have scale up, scale down like that generally. Almost nobody has that type of workload for their data, but you do want to make sure that you have a rack-aware setup where you make sure that replicas are on different racks. And in AWS's case, it means different AZs. And so there's definitely support in the integration that we have between Dcos and Kafka. Absolutely can handle that. You basically can tag the instances when they're being added to Mesos, and then it can schedule appropriately to make sure that you get spread across multiple AZs. And you can do the same thing for any other application. It doesn't have to be Kafka.
Thanks.
So that's the same with Kubernetes also. You have those labels, and when you go to schedule, you have an anti-affinity, right, type of label where you say, make sure this one's not on the same. Yes, one thing to point out too about the data locality, because yes, I see this all the time. For the types of workloads that my company now, Pipeline IO, does, it's a lot of machine learning, a lot of AI, compute intensive, right? So, and this is something I picked up at my old company Netflix before Databricks, which is the first time I'd ever seen no HDFS and all S3, right? So all of this data was being remotely pulled in, but it's because of the type of workload, which was very compute intensive, right? That was dominating, not the actual data transfer. So yeah, we were able to kind of skirt around data locality, but that's not always the case. So.
Any other questions so far back there?
Hi, I was wondering if you can go through an example from start to finish of one use case that uses the SMAC stack and how they used it for each part of the SMAC stack.
I think the reference implementation was the dating site. You ended up doing the dating site? The Spark After Dark. Yeah, that was my idea. I was using it for, just for my own little sandbox environment. At Databricks, for example, I was not allowed to use any other tools except Spark. So I basically had to make Spark a database. I had to make Spark do everything. And so of course that doesn't work. So on the side, I had to kind of hide from my old bosses and do talks on other things besides Spark. But so it was Spark streaming was taking in the ratings. So we would show people pictures of like celebrities, or, just like random things, and they would rate those tuples, the user ID and the rating, or it was the user ID of who was doing the rating, it was the item ID, which was the actor, actress, and it was the rating, from 1 to 5. So that was going across Kafka. It was being picked up by Spark streaming Kafka integration. It was then being written to Cassandra right away, so pulling it off of Kafka. This is in Spark streaming, using the Spark Cassandra connector, and then writing it out. And so that was, and then on the get side, the person, if you click refresh, it would then show you recommendations based on, and then, then that also kicked off a Spark ML. It was just doing ALS behind the scenes, right? Alternating least squares, or like collaborative filtering. And then every, like minute or something, it was generating new recommendations, sticking it into Redis, and then pulling it, and showing the user. So, and I think we forced in AKKA somewhere. Yeah, right. Like you weren't there, but we had to. I think it was Ryan. Yeah, that did it. But yeah, AKKA showed up somewhere.
Yeah, I mean, I guess just to add to that a little bit, I mean, it's basically using Kafka for event sourcing. So you're recording raw events in Kafka, and then you want to push it into other systems for processing and for querying. So you push it from let's say like into Cassandra, because then you get efficient querying or certain types of querying. You put it into Spark for sort of analysis. So you're gonna get it loaded. Well, I guess into Spark via, it could be either the Kafka integration. I don't remember what it was back in the day, but you're getting into Spark, and then that's sort of for massive analysis. And then actually AKKA is, you don't really have to force AKKA in. What you're going to want to use AKKA for is probably something where you have, you want to process the actual streaming data. So rather than taking the raw events, maybe you want to do something, you want to get aggregates, you want to get analytics for like online analytics for your site, something like that. You can handle that with AKKA.
Can you comment on like what customers are using your technology for, like some interesting use cases? I know there's some people in the crowd using some of these technologies. I don't know if someone wants to volunteer, like what they're doing like today, besides dating after dark or.
So I'm not going to name specific names, although there's quite a few out there, especially the big Silicon Valley tech companies that obviously talk about this a lot. Kafka is sort of, I mean, you sort of use it for everything, so it's a little hard to pin down to a specific application. But I will cover a couple of different options. So you might be using it for analytics. So this is actually probably one of the original use cases, is just capturing raw data so then you can pipe it downstream to be analyzed, possibly dumping into something like Hadoop or into Spark, S3, whatever. So that's an initial one. We now see it being adopted across a large range of industries. So retail, they're using it to track all of their inventory, where it's going, where they need to send more product. Using it in car companies doing IoT solutions. They're basically delivering data from their car into Kafka, then we're passing it down. They're either trying to analyze stuff real time, so that would be, again, an AKKA use case, or pass it downstream to Cassandra and things like Hadoop for then analysis in Spark. Let's see, what other industries am I missing?
I can I mean, it's pretty much along the same lines as that. Is we see a lot of folks. Something I've seen more common these days is reward systems for, you can imagine, like coffee shops and things like that, where you have a constant incoming stream of events that are, need to be totaled for every customer. You need to have a persistent record of that, and that's why you need Cassandra somewhere in there. And you have Kafka because you've got so many things coming in, and you have to do kind of live updates to their state so that you have things that make sense for that customer, because if they earn 10 magic points, they better see 10 magic points when they check on their phone, or they're going to go back up and be very upset to whoever they just bought what they bought from. So we'll see data coming in through a Kafka queue, going into Spark streaming. And then we see that's where we'll have a layer of analysis or something like that. If you're familiar with Cassandra, you'll know that not all query patterns are possible with the way you lay out your data. So you'll use that step in Spark streaming to move around your data or adjust it so that the data that you need to have available at a quick lookup is ready. Then you'll write that out to Cassandra, and that's basically your constant streaming application that's running. That's kind of the back-end picture. On the front, you then have, your website, which might be based in AKKA, might be based in some other thing, and that's where you're getting your live requests, which access the data in Cassandra, which is going to basically be your store of truth. So your customers will never really interact with the back-end portion. They only interact with the database through your website and only those select pieces of data that you've analyzed for them. And then the whole setup, of course, is going to be managed by something like Mesos. I don't know if you want to talk about that. Cool.
Neil, I have a question for you. So there was some questions about Kubernetes earlier. So I was curious on your take on, what's different about running these technologies on, the Mesos platform versus just like containerizing Kafka or Cassandra or trying to run that like on Kubernetes or something else?
Right. So I'm not a Kubernetes expert. I won't claim to kind of, talk about Kubernetes in any detail. I do think, though, that the problem that these systems, or the problem that we're trying to solve at Mesosphere, is a lot broader than just container orchestration. That's a requirement for, building these applications and delivering the value, but there's a lot more to it than just container orchestration. So running these large stateful services over persistent data, integrating container-based applications, data analytics applications, giving you experience like, a lot of people who are running on-premise data centers would love to get the experience they're able to get in the public cloud, or they would be able to get in the public cloud. But operating those data centers is just really painful right now. Trying to solve that problem is a much bigger problem than just container orchestration in the narrow. So I think that's what we're trying to attack at Mesosphere, is kind of that bigger problem of how do we develop distributed systems, how do we deploy them, how do we operate them in a way that is portable across environments, on-premise, on cloud, and really unlocks the potential they have to a very broad audience of customers. Because right now, getting this value is really kind of rocket science. And if you kind of accept that a lot of most companies, all companies have to be software companies, it does need to get fundamentally easier to do this stuff and to get value out of that opportunity.
Questions from the audience? Anyone? Back here.
So you asked about use cases. You asked about use cases, and you have a gentleman on the panel from Credit Karma. Can we hear what Credit Karma are doing?
Absolutely.
So we don't use the entire SMAC stack. I'll just get that out of the way now. We do use Spark, we do use Kafka, and we do use AKKA. Unfortunately, we don't use Cassandra as much as I would like to, and unfortunately, we don't use Mesos as much as I would like to. But that's how business goes. So what we do at Credit Karma, I'll talk about AKKA first, because that's what I'm supposed to do. So we have a data science team that comes up with a bunch of predictive models for a whole bunch of different offers. If you've ever been on the site before, the way that we make money, I just want to preface it by this, is that there's no subscription or anything like that. It actually is free. But when you go to the site, you'll see offers for things like credit cards, personal loans, a whole bunch of different financial services. And next to those, a lot of times you'll see things like approval odds. Those approval odds are calculated in an AKKA cluster, as well as the some different models that try and determine what your likelihood to interact with that is. Given your likelihood to interact with it, what's the likelihood that you actually go through the approval process, and so on until you actually get approved. Because the only way that we get money is if you get approved. So it's in our best interest to kind of make sure that we're showing users the right thing. We use AKKA in production for the computation of our data science models. We have somewhere around 1,000 of them at this point, and at any given request on the site, you're likely to be evaluating, your request is likely to trigger somewhere around 100 to 150 models that get spread up across a 400 core cluster and then returned back to you in somewhere around 60, 70 milliseconds at the 99th percentile. Doing that with AKKA was actually super, super, super easy because it has its clustered setup. So that's from the AKKA side. Again, if anybody is interested in any of this, please come find me after. From the Spark side, we actually use that to train all of our models. And the important part when you're training is the data, which a vast majority of it comes from Kafka. So we have a whole bunch of data being ingested as users are clicking on things, taking offers, browsing around the site. So we have all kinds of tracking data that's coming through. I don't actually remember what the rate is at this point, but I want to say it's somewhere around 700K events per second, something along there, which for some people is going to be a lot. For some people, it's not going to be that much. And so we process all of that in other AKKA systems that are actually written in AKKA Stream. And from there, we do all kinds of cool aggregations in Spark and then use that data on the AKKA side, very similar to actually what you were saying, just without the Cassandra part, unfortunately.
You're missing out.
I know.
I guess he was first, right? You want the? I don't want to hear him.
Oh. Yeah, so does Critical Camera use containerization? How do you manage your infrastructure if you do not use the Mesos or Kubernetes?
Yeah, so for a long time, a lot of it was just done on bare metal. Nowadays, as we're building out more and more services, all of them are Dockerized at this point. We manually maintain the Docker servers that we have, and I don't want to get too far into it because it's a pretty big rabbit hole and not necessarily relevant. I don't recommend it to anyone. But again, if you're interested, come find me and I will explain more.
Okay, so another question is related to the persistent storage. So I'm just wondering, in large scale, how to deploy the, for example, Kafka into a lots of container, but how to solve the persistent volume stuff? I mean, for example, you need to persistent all of the stuff, all of the data into persistent volume. So how to solve the conflict? I mean, in one box, we can only map one volume to the container. If in large scale, how to solve the persistent volume stuff?
In terms of Docker volume?
Yeah, Docker volume, yeah.
Oh, okay. I can't say that that's something that we use, at least not for actual real persistence. Things like config files or something like that, maybe, but not for any of our databases or our Kafka instances now.
Maybe I can. Yeah, absolutely. So am I understanding the question correctly? You're asking basically how do you deal with mounting volumes into the Docker container so that then Kafka's storage can be stored into a new container?
In large scale, I mean, how to resolve the conflict?
I think the short answer to this is you should just, especially if you're running on Mesos, you should just use the Dcos integration for Kafka, which takes care of this for you, and you don't have to think about it. The sort of slightly longer answer is that I mean, Mesos basically has a way to be able to restore the state and do the mounting for you. So even if you were managing it sort of a little bit more manually in Mesos, I mean, at some point you actually do run into a problem where like a node dies or something and you can't restart it on that node. In Kafka, since things are already replicated, that's actually okay. If you are forced to, you can bring up the container somewhere else without any state and it'll end up re-replicating the state from the other nodes that are still online. So it's really just about preferring to be able to remount that data, but it's actually not critical that you're able to. And so actually before there was good integration and a good framework, good Mesos framework for doing this, the way that people would do it is just run it effectively under something like Marathon, and you just sort of suffer with the fact that sometimes you end up having to re-replicate data. But the better solution now is that there's an actual scheduler that handles this for you.
Okay, thank you. So can I ask another question? Sorry. So the another question is that in production, I'm just wondering how many Mesos clusters do I need to spin up, for example, or so if I have a very big environment, so probably I need to spin up more than one Mesos cluster, and how do I manage these two separate or several separate Mesos cluster?
So the question is, at what point do you need to start running multiple Mesos clusters?
Yeah, right.
Right.
Yeah.
So Mesos itself is very scalable. There are people running north of 30 or 40,000 nodes in one Mesos cluster. Okay. That being said, you don't necessarily want to do that because if that does expose you to the risk that if there is, let's say, some kind of bug in the Mesos master that can harm the availability of that whole cluster, which is pretty meaningful slice of resources. So a lot of people will end up dividing that larger pool of machines into a smaller collection of Mesos clusters, just depending on your workload and kind of your risk tolerance. Then once you have multiple Mesos clusters, then making those work together becomes a little more challenging than if they're one unified Mesos cluster. That's where federation and those kinds of multi-cluster, multi-data center features come in, which is something probably Mesos is a little behind Kubernetes at the moment, but it's something we're working on is federation support and improving multi-cluster operations.
Okay, thank you.
Got an AKKA question. So we're looking at some high availability patterns. To invoke cap theorem, you can sort of choose between like the CA-ish model and have it do like some kind of master type setup, have like something hot, some nodes on standby. And use something like etcd or Zookeeper for that. We're also looking at AKKA cluster for more of like a either CP-ish or AP-ish type system where we can afford some sort of partition tolerance, some partition in the network. What are some patterns that you've seen using AKKA for building highly available systems? And do you see some folks leaning more towards the AKKA cluster toolkit, and in cases where you do see them, like what are the use cases for that? And do you see people using more like the CA-ish model where people, kind of like Marathon, right, is high availability is achieved using Zookeeper with Marathon, and like in the whole Java ecosystem, a lot of stuff is made HA through Zookeeper. What are some of the patterns that you see fitting?
That's a good question. Let's see. So I'll talk a little bit about how our cluster works, since we are using AKKA cluster. Some of the things that it provides that are really, really, really nice are, I was talking to somebody earlier, actually sitting right next to you, about how we went from running replicated machines that were not part of a cluster to running in a cluster in about an hour, which is awesome. That plus the ability to very easily auto-scale that cluster up or just scale it regardless, it doesn't have to be auto. To a point where we actually didn't need any extra systems like Console or Zookeeper or something like that. So that has worked really well for us. We have other pieces of our infrastructure that are written more, I guess the Twitter stack is one of the things that we use, and that is more on the using Console for service discovery or Zookeeper or whatever you happen to use instead of letting the AKKA cluster handle that kind of stuff for you. Both of them have their advantages and disadvantages. What I can say is that using the AKKA cluster was extremely easy and it required only application level support, no infrastructure level support, whereas using something like Zookeeper is going to also require infrastructure level support. which is costly and might not actually be effective for what you're trying to work on. Yeah, hopefully that answers your question.
Hi, I have a question around Kafka, and like, let's say I'm running active Kafka cluster in 2 different regions. Is there like an easy way for me to maintain like consumer state if it has to fail over to start consuming from the other region, assuming like the data is like completely like replicated?
So when you say active mode, do you mean you actually have 2 separate clusters? It's not like stretched across
Yes,
the 2.
that's correct.
So for active in that case, you actually have to have each topic basically owned by one cluster. So I'm assuming that's the setup that you're, or sorry, not like owned in the sense that like you only produce to that topic in one cluster unless you're in the process of failing over. Right, because active you would just get replication cycles if you didn't do that. So if that's the mode that you're talking about, then there isn't today an easy way to fail over. We did some work. We actually built at Confluent a product to help with replication. We have some additional tooling for failing over. We're sort of in the process of improving that. The fundamental problem there, I can give you sort of the nitty-gritty technical details. The fundamental problem is that the way that replication works across 2 clusters, there's no mechanism in Kafka to say start replicating and preserve the offset from the source cluster to the destination cluster. What your option today is basically when you do failover, you can do timestamp-based querying, and so you can. We don't provide the tooling today, but you can basically do that query in the new data center to like where you want to, what timestamp you want to fail over to, and then just initialize all the consumer offsets by seeking to them. So today you'd have to do that by hand, but honestly, it's like 3 or 4 lines of code. It's not that complicated. Back there.
So a bit of a broad question here. Scala or Java 8?
I'm
not going to touch that one. I don't know if anybody else wants to.
I've got plenty of offensive things to say. I'm a big Scala advocate. If you're getting into Spark right now, Scala is going to be considerably easier until the Java 8 support is a lot better. Right now, you spend a lot of time if you're writing your application. If you're writing it in Java, passing around class types, getting class types, knowing what type parameters your map function has and your output has. Things are a lot better if you're in the data frames, data sets world, but then you still have to manage encoders. And if I'm saying a lot of things right now that you're like, I don't want to deal with that, Scala's going to do it all for you, while Java will not. Even Python is kind of better at that because Python doesn't really care what type anything is, so it just handles it on the fly, which is great, but also not great. So I'll say Scala, but the JVM is great. The JVM is a great piece of machinery. It's got a lot of great tooling around it. You really can't go wrong doing Java or Scala based on what you feel comfortable with. But if you're about to start your first Spark application and you don't feel confident in Scala, it might be worth taking a look at it just because it might save you a lot of pain down the line. That's my bit. Yeah.
Okay, so sort of, it depends on the type of application you're writing. But one thing that I will note is that Kafka was originally written in Scala. That actually creates a huge number of problems because we have client libraries and we needed people to be able to use them from Java as well, which was terrible. So now all of the clients have been rewritten in Java, and actually a substantial part of the broker is now getting shifted over to Java just sort of implicitly because we share code between the clients and the broker. One of the reasons that was possible is because there are basically 2 ways that you can write Scala code. You can write Scala code that basically looks like Java but takes advantage of a few of the niceties that Scala provides, or you can write code that nobody else can read. Or only crazy functional programming language nerds. I would say actually it probably doesn't matter that much if you jump to Scala, but it's more about how you use the Scala than necessarily making that decision. That said, I also can't stand developing in Scala because the compile time is way too slow. So it really hurts your iteration speed.
Yeah, so similar to Kafka, Spark has actually right? I mean, it's still very much Scala heavy, right? Like the full code base itself, but parts of it, and so things like Project Tungsten, things like the dynamic code generation when it's going from a logical plan, and it's dynamically generating source code, that's Java source code, then that gets compiled into bytecode and then cached. That was the second part of Project Tungsten. Some of the earlier things that went from Scala to Java were, I think it was the Netty implementation, the communication between masters and workers and things like that. Funny enough, AKKA was actually, I think, removed in Spark 2.0. I don't know the specifics, but there was something too, I think, about the random ports it would open and over firewalls. That was, oh, is it really? Yeah. And I think the way that it was being used within the Spark code base, I think just simple REST APIs were, but most, so my point is most of the really low level optimizations that are happening with these things, and I'm sure this happened with Kafka as well too, had to get written in Java, right? Because of things like Netty and some of the other libraries that they were relying on, which were Java based. I spend a lot of time going back and forth between Scala and Java, which is why I cringe at this question. Mike, you're one of the first people. You came down to Netflix. Was one of the first times it was back in the early days when Netflix was looking at Scala. Yeah, right, exactly. ScalaCourses.com. All right. Yes, I always found you funny with the meetups because, I think you'd be ending a consulting gig and be like, "I'm available," and it was the perfect audience because they're all. And so trying to go back and forth between Scala and Java is a huge pain just because of the functional stuff. And I do a lot of Python now too because of just working with a lot of data scientists, and so trying to do PySpark and figure all that stuff out. But I actually kind of like Python from a quick and dirty, but I still get burned by the not typing, by the no types. That drives me nuts. So. I'm trying to build a framework within Python to give to data scientists to deploy a model, for example.
I mean, I love Python, and a lot of what we're talking about, the whole Tungsten Catalyst, all of this stuff is available from Python. You get all of those optimizations that were written with the low-level code. All of that happens automatically. For me, the big thing is still just if I'm writing Spark code, and I think if you go online, you can see Holden's done a ton of talks on this, but you never really want to have a Python Lambda in your big data ever, because there's just a huge amount of penalty from serializing out of your JVM objects into a Python object. And then, of course, when you're going back into Spark again, you have to serialize it back into a JVM object. And you can imagine that that's very expensive. So use data sets.
So Aaron at the beginning mentioned the two-tier scheduler with Dcos. I was wondering if you can elaborate a little bit more about what that means and does in the relationship to Marathon as well.
Sure. So the concept of a two-tier scheduler is trying to create a separation of concerns. So Mesos itself does the low-level resource management. So it manages actually launching the containers, deciding which resources are available on which nodes, and it implements a very kind of an initial notion of which cluster users should get which resources, but it doesn't try to decide which workload should run where. So the actual decision of, given the resources in the cluster, how to make use of those resources, what workloads to run, that's run on an application level scheduler. So that's going to be, a scheduler for Kafka, or scheduler for Cassandra, or what have you. And the other thing, so we initially called those pieces of software schedulers, and certainly they're doing scheduling. And just to clarify, so the reason that you want to have application-specific schedulers is that it would be very hard to write an optimal scheduler, an intelligent scheduler for all possible workloads for your cluster, and to bake that into Mesos. So Mesos tries to take this approach of being very scalable, very simple, very minimalistic, kind of like you know, the Linux kernel. I mean, it's not the most minimal system. Microkernel would be more minimal. And Mesos kind of takes that kind of a microkernel approach where you try to avoid putting policy in Mesos. You try to put the application-specific logic in the schedulers. So that gives the opportunity then to write a really good Cassandra scheduler, a really good Kafka scheduler that really understands the properties of Cassandra workloads or the properties of Kafka workloads. It's written by someone who's a Kafka expert, a Cassandra expert, without having to bake that all into Mesos. But I think the other thing those schedulers are doing, and that's why I think the term scheduler is a little misleading, is that part of what they're trying to do is trying to take these prepackaged software services like Cassandra and turn them into intelligent services. So to make it so that you can deploy Kafka, or Cassandra, or each of these services in a very straightforward way, scale them in a very straightforward way, have kind of a unified interface to understanding which applications are using which resources. They're kind of like, we call them kind of service backplanes, where they're sitting between the service software, like let's say Cassandra, and then your infrastructure APIs, like your AWS or GCP APIs. They kind of sit in the middle and they mediate, and they say, okay, if there's more workload, if there's more work required, you can move more workload to a free server, or if you want to upgrade one of these service schedulers, that kind of backplane or the scheduler provides a convenient way to do that. So to try to make running these services like fundamentally more easier and more self-managing.
Piggybacking on the scheduler question, so Mesos, right, is a two-phase scheduler. There's also a shared state schedulers, which sort of invoke a different sort of concurrency model. Well, what are the trade-offs between the two, and when is it appropriate to use one versus the other? And I think there was a paper by some of the Google guys. I don't know if Hinman was on it. Maybe I think some of the Databricks guys were on it, but some folks were doing like internships at Google, who were writing about like Borg and Omega, Kubernetes, and all those things. Some of the ideas there were eventually baked into Mesos. But as far as like the different scheduler options out there, like how do they kind of compare, and like when do you use one over the other? And I'm sure there might be some deep academic reasons for that. If there are any papers you could cite.
Sure. I mean, so there's a bunch of different approaches to scheduling. And I think you're also starting to see those approaches converge in some ways. So just a kind of rough overview, Mesos is two-level. So you have a kind of a generic infrastructure level scheduler and then service level schedulers. And then it's pessimistic, which means that when it offers resources to one framework, those resources can't be used by anybody else until that framework has decided either to use them or to decline them. And there's a bunch more, so you can either be monolithic or two-level, you can be optimistic or pessimistic. There are a bunch of dimensions, and different schedulers are playing in different parts of that space. But I think they're also converging where some of the advantages of, or there are different trade-offs between those models. So one thing we're looking at adding to Mesos, for example, is adding optimistic capabilities to Mesos. So the idea there is that we would essentially kind of offer all the cluster resources to all the frameworks, to all the consumers, and then they could try to use those, and then as they submit requests to use those resources, some of those requests would be turned down if there's a conflict where two people want to use the same thing. So we can certainly go into a lot more detail. Maybe kind of the details we can talk about offline, but I think that's kind of the high level, is that it's a very rich space and there's a lot of options, but in terms of what people need in practice, I think it's kind of converging where you need certain kind of requirements in terms of being able to guarantee resources to certain clients to ensure that the rest of the resource, trying to balance cluster utilization between maximizing utilization, but also maximizing fairness so that people don't get starved. And then if you want to meet those requirements, you can kind of do it with a couple different approaches. And as I said, the kind of popular approach, I think, are kind of borrowing from each other. So.
Hi, thanks for the great SMAC overview. I wonder, how do you connect this in general to machine learning AI kind of hype which is happening, right? It looks like SMAC stack is a good way to run machine learning pipelines, and Credit Karma, I think, is a case in point. But I wonder, are there any patterns for end-to-end data pipelines in production where you run industrial-grade algorithms which are not Python?
Anyone?
Yeah, so the whole like company pipeline IO was built around this, right? So yes, I appreciate the setup. That was nice. Yeah, thanks, Alexi. Yeah, the whole end-to-end. So basically getting data in, doing, if you think of your feature transformations for the machine learning algorithms as just kind of straight up ETL, right? They're just like different types of transformations. So yeah, for that, we're using Cassandra, we're using Kafka. And then there's now ways to get TensorFlow, for example, to talk to HDFS, which is really handy. And yeah, so TensorFlow, I'm just kind of like brainstorming here, but yeah, TensorFlow kind of has their own file format. It's called TF record, which would, I guess, kind of be the equivalent of like a sequence file, if you guys are, familiar with some of those early on, or like an Avro or something like that. So, but yeah, I mean, SMAC is it's it's a platform level kind of thing. So yeah, with like AI and ML, these are just use cases on top. So I believe people, right, like Uber and, yeah, they're all using forms of SMAC and things like that, right? So yeah, for all of their ML.
I guess two generic patterns I can think of off the top of my head is you have your time where at the end of the day you run some kind of process where you take a huge amount of data, you train your models, you store those models, and then load them into a streaming processing part of your job, which takes that last day's model and uses it to do new predictions based on when a user comes in. Another thing that, actually, I've got three options. Okay, another one is where you have a batch job at night. This is, I wish there was someone here at Netflix who could correct me if I'm wrong on this, but where I think at night you take the entire set of data and you make all of your predictions for the following day, store those in Cassandra or some kind of other durable store, because people don't really care on that kind of application, whether they got an instant update to what their recommendation is. And then you can also have machine learning algorithms that are constantly learning as new data is streaming in. And that's where you need a specialized kind of algorithm that you kind of bake into the streaming layer. And then as the data comes in, your model is both evaluating and training based on whatever outcomes you get. And you just basically are constantly updating as you go through. I don't think that the ecosystem is really mature enough to say any of these are easy out of the box solutions. They all take a lot of kind of researching what you're doing, what your model is. And my one big worry with all things ML is you need to really know ahead of time what you're trying to do with your machine learning before you start doing it. It's very easy to convince yourself of things that are not true if you just start throwing data at math.
So while that is true, I would also say that the stack also makes it easy to experiment with this stuff. So yeah, there is some setup involved, but the pattern that I see most, in fact, actually I haven't really seen anybody in practice doing online learning. It's really hard. You also don't really have any chance, if you do stuff online, you don't really have any chance to validate your models, which makes it a little riskier to use. So the pattern that I see most frequently is batch job on Spark or something like that to do to generate the model, and then you apply it inline using whatever stream processing framework, oftentimes based off of events directly in Kafka is the one obviously I see a lot of. And so you can apply it in line, but one of the nice things is the stack also, if you, for example, pass your raw data through Kafka first, you have or you train multiple models in Spark, you have an opportunity to basically just farm this out. So like the pub sub nature of your streaming data actually becomes really important there because it offers you the opportunity to try a lot of things in parallel.
Right, so I'll mention like one more thing too about TensorFlow that I've been seeing more and more of, and it's not TensorFlow specific, but at sort of larger scale, you're like constantly training, and you can spin up a bunch of like servers. You have a huge training cluster that's pulling in batches off Kafka or off somewhere. And then typically you're like checkpointing, you know, the weights or the parameters, the variables that you're learning. And when you checkpoint, you then want to have some sort of sensor or some sort of way to then kick off a validation cluster, you know, like a smaller cluster. So every, you know, hour or something like that, when you're checkpointing every half hour or whatever, you then want to, at the same time that you continue on the training side, also spin up a validation on that current checkpoint. And if the model validation starts to show overfitting or other weird signs, you want to propagate back and stop the training. So yeah, that's a big pattern I've been seeing more and more of in the TensorFlow world. The online training stuff works better if you have linear models. You know, again, I'm just kind of spewing things out here. What's the other thing about online training? If you've ever used Python scikit-learn, so there's a method called partial fit, right, that a lot of people don't know about. There's the traditional fit, which expects all the data and you know, on a single node, because scikit-learn's not very distributed. But there's this sort of second method on specifically linear models, linear regression, logistic regression, where you can continuously train, and the name of it is partial fit, and you're, you know, kind of partially passing in data. And with these neural networks, yeah, so back to like TensorFlow and neural networks, like they're sort of always ready to keep being trained, right? Because when you take checkpoints, when you save off the current values, they're meant to be restored and then training continues. So you could sort of always think of these neural networks as having the ability for like continuous training, but it's not always the best thing, of course. But yeah.
Awesome. Any last questions as we're lowering down in time?
We're a little hotel software as a service company that uses everything except Mesos. We can't afford it yet, unfortunately. But we're sort of in that middle territory. We can't really use anything else because we, you know, need to process something like 5,000 to 10,000 messages a second at times, and we don't, you know, we can't really go full enterprise, etc. And obviously, it's very understandable that an immense amount of work goes into building each of these platforms, and the companies that do that need to make money. I was wondering if each of you, or at least those who are representing your respective companies, can talk about whether it's your personal opinion or any light that you can shed on kind of how the open source community is, how it will be supported in the future, and whether there are any kind of larger trends in what features will be supported in the next year to 3 years, something like that come to mind, and kind of what we as a company can do to sort of prepare for any changes that might be coming in the future to support the needs that we have. Should we start saving money?
Definitely, save your money. So is that for all the
yeah, that's a general question to
basically?
anyone who feels inclined to speak to that.
Yeah, the cost savings thing always comes up. We have this feature within Pipeline.io for this auto traffic shifting. So there's auto scaling, of course, where you scale up, but think of you lose your spot instances within Amazon. You're doing, you know, X number of predictions per second at some price, and now you can shift over, right, like maybe Google is cheaper at that moment. So the thing with cost savings, and you know, this comes from, I've been talking to a lot of VCs and founders recently, and yeah, they all say the same thing. Right now, don't talk about cost savings. No one cares. It's not. So I'm personally a pretty frugal person. So and I'm a founder, so I have to keep an eye on all the like Amazon bills and things like that. So cost savings to me is important, but I guess that, for like people like Netflix, it's like millions of dollars per month. I think the other big trend is continuous, like this term continuous, where obviously Kafka is huge. You see Spark using that term continuous, continuous applications is the term coming out of Databricks a lot. Also, one negative trend I think is right, like closed source, right? You see Databricks the next few days. I'm very public about sort of bashing them for going the closed source route. I mean, you have to do it, again, because of VCs, you have to make money. But a lot of the new things that you're going to see at the Spark Summit that are announced are going to be Databricks specific, right? We saw this with DataStax. We see, I think the first time I saw this with DataStax was when you were treating your Cassandra cluster as an analytics source, right? As a bulk read versus the traditional, right, like transactional fast writes. And the way Netflix did it, we had separate clusters, and then we had gone away from separate clusters, and we went straight to the SS tables. And this was all Netflix created custom code. You would you go straight to the Cassandra SS tables, you would do your ETL that way or your bulk reads that way, so that you weren't going through the Cassandra front door. And then I think there was something similar for Spark, and then it was supposed to be open source, then it wasn't open sourced. It's closer, so it's just natural business stuff, but yeah.
Yeah, so I guess one thing to point out is that infrastructure software, basically today you can't go like closed source for a bunch of stuff. It's just you'll lose if you do that, like regardless of your existing position in the market. So in a lot of ways, I think you should feel okay about the future, because I think it's most of the important stuff is going to remain open source. It's sort of interesting to hear about Databricks because I think it's an unusual choice. I do work for a company that makes proprietary stuff around Kafka. That said, a very large fraction of our platform is also open source. And generally, the way that I'd say, it's obviously on a product by product decision. But I tend to think of it as the stuff that we're going to charge for is the stuff that big enterprises are going to want to pay for anyway. And so the stuff that's open source, we're sort of like open source by default, I would even say. Yeah, but I think just by the nature of the trend in infrastructure software, everything that you see up here, I think you'll be in a perfectly good position moving forward. Nobody's going to cripple the sort of open source product because honestly, a lot of where customers flow in from is from smaller applications that then eventually grow. And so you need to hook those people when they're only using the open source stuff. The other thing that I'll point out is that think hard about where your costs actually are going. If you end up using the open source version and operating it yourself, you may be spending a lot more money than if you just go with one of the hosted solutions. And of course, I have to then plug Confluent Cloud, which is we just announced recently. So yeah, the other thing there is I'd say hosted versions, it's sort of like anti-lock-in because you're still hosting on something that you could eventually move to an open source, just like open source version managed yourself if you wanted to. But it, oftentimes will be a very high cost savings over having to pay like another ops person.
I guess one trend I'm seeing a lot is, and this is definitely from a DataStax perspective, it's one of those things where it's really important to have open APIs so that this lock-in doesn't happen at your application level. But I would expect to see a lot more kind of enterprise differentiation coming in these products because, I mean, if you take a look at all the big cloud providers, they're definitely moving towards trying to provide their own hosted versions of all of these components. And when that happens, the question is, will they back these projects? And the companies that are currently investing a lot of money, I know, want to make sure that they have a place in the market, that they have a place to continue doing their work. So I do think that you will definitely be able to interact with any of these components and their open source versions in the future, but I think there'll probably be more differentiation between the enterprise version and the non for a lot of components.
Yes, a question about that for that graph database Titan,
Yeah.
for example. So Titan got pulled into DataStax. Is it, and they sort of stopped the open source side of it?
Well, so the open source side actually, the project got picked up by some folks at IBM who took it and you know, the question is, where does it go from there? Will they continue putting money into it? But at some level, they wanted to make, at DataStax, you know, you want to have a company that makes money, that sells things that people use. Yeah, this is kind of how that worked out.
That was one of the, yes, I don't mean to keep dogging on DataStax, but that was one of the times where if I was using Titan and then all of a sudden it gets slurped in and out, and IBM didn't pick it up, but people have.
I mean, the project's there for anyone to pick up. I mean, the big underlying question in all this is, who are you going to pay to write this software? And if no one's paying anyone to write this software, it's someone's hobby project. And at that point, they could always stop. So just something to think about.
Sure. All of that makes perfect sense. And I think we're one company probably among many who have been extremely successful with this stack. And we're still in the process of growing. And so we're in that kind of awkward territory of, you know, being ready to pay for the product as soon as possible, as soon as we, you know, keep growing and things are going very well so far. But obviously a little bit nervous about the foundation that we've built at this time. So all of that's very helpful. Thank you.
So maybe just to add my 2 cents, sorry, it's not a question, guys. We're a company that kind of landed on the other side of I guess, a large company kind of saying, hey, we're going to go enterprise and we're not going to really be too participative in the community anymore. And I guess it really brings to mind a saying that you hear a lot of people talk about when it comes to open source. It's you're going to pay for it in some way. One is going to either come down to money or it's going to come down to time. Right, and so once you've kind of got that cost equation, you then look at what are the other benefits of open source is, you know, yes, you can get other people to run it and you leverage open APIs. You can potentially leverage, you know, many eyes looking at the source code as opposed to just a single set. But then at the same time, it means that you're not potentially focusing on your core competencies as well as a company, right? So for every company, it's going to be a trade-off for how important that particular technology is. And we've actually seen a lot of companies where they've made a decision whereby, you know, some kind of peripheral services, they're like, look, we're just going to pay someone to do it because it's far easier. But for other things, they've said, actually, this is a core of what we do, even though, hey, we're not here to be database experts, we're not here to be kind of, you know, infrastructure management experts. It's so critical to what we do, we need to build expertise in this. And that's why they've gone down the open source path.
Yes, I just want to mention one thing that I think the SMAC stack doesn't sort of emphasize, which is unfortunate, but is sort of monitoring and, you know, metrics collection. All of these tools, right? Like all of us up here get questions all the time. How do we tune Kafka? How do we tune Spark? How do we, you know, right, like tune like Dcos, things like that. And right, like my first question is always, well, what kind of what sort of metrics are you even trying to optimize? Like what do you have set up, right? Like how do I know if I do, you know, give you 5 magical parameters that they're helping your specific workload and all that kind of stuff. So yeah, so we tend to use Prometheus just because it works nicely with Kubernetes and things like that, but Spark and Graphite work really well. Kafka, I think for like Kafka, it's like JMX is what you guys always...
Well, it gets exposed as JMX by default, but it's actually pluggable, so you can pretty easily integrate it with whatever you want.
Yeah, so I've been to a couple Kafka talks recently, and they were debugging talks, you know, which are the best ones. It's, yeah, either you guys, like your solution architects, or people using Kafka. And they just talk about these super obscure problems that there's no way that they could have debugged on their own just from an outsider. Like you really, really needed the JMX metrics in some central place to see the changes. For Cassandra, open source, is there like what?
Open source has the same JMX list for all of that.
But then there's like DataStax Enterprise obviously has a lot of the, yeah.
There is, I don't know enough about our product. But
yeah.
We have an ops center service that, you know, basically reads all those JMX metrics. So far, the same underlying
Gotcha.
exposure.
And then for like DCOS, there's
I mean, Yeah, for DCOS, we kind of expose a bunch of metrics endpoints, and I know DCOS, so Mesos exposes metrics endpoints. DCOS integrates with, is it Datadog? Okay, I think we integrate with a bunch.
All right, I'll take a question. The sales guy in the room now. Yeah, so we do have, I mean, I guess what I heard, right, is that most organizations that I go into have their own set of tools, right? They already do. They already do monitoring. They already have a way of doing it. So all we're trying to do is make that simple, right? So a single way of getting logs out of the system, a single way of getting metrics for all the things that we just talked about, right? So metrics at the infrastructure level, at the orchestrator level, at the service level with some of these technologies, and even at the application level, like providing endpoints for you to publish metrics to and then pull into your tool of choice. So Prometheus is one. There's lots of open source tools. There's lots of proprietary tools that you can use that customers already have in the data center, right? So